Hi friends, welcome to the Unit 6 Day 1B notes. This set of notes talks about multiplying radical expressions. In the previous one we were just talking about simplifying. Now we're going to be multiplying. This starts off, each of these 3 days starts off with these perfect squares lists. You should already have them down. You should have them in your brain. You should have them not necessarily memorized, but close to it. You should be at a point where you feel really comfortable with it. And I'm just going through and marking down the ones that I remember off the top of my head. Let's see if I got any better between last time I recorded this and this time. So, those 10 I usually have perfectly, don't have any issues. This is where things start getting a little bit dicey. 144, 169. Now remember this one because it's the backwards, 196. I think that's 225, but this is the one I'm never quite confident on. Yep, 225. I have it down here. I'm looking down below. 256, I think. Yep. And little off here. 324, 361, and then that one is 400. I usually get that one just fine. All right, now that we have that, let's go ahead and multiply. The 3 steps are multiplying radical expressions. You multiply the coefficients together. Remember, the coefficients is the number in front of the radical sign. Then you multiply the radicands together. Remember, that's the number that's underneath the radical. And then we place that number in a radical, and then we just simplify. So we also need to remember that we need the coefficient as well. So for this one, this is the first example, simplify each radical expression, circle your answer. We're multiplying, so now we're going to multiply through square root of 3 times the square root of 2, or radical 3 times radical 2. So then we just multiply the coefficients. 1 times 1 is 1. I'm not going to write anything down. But then we have square root of 3 times square root of 2, which is square root of 6. Now I check to see if the square root of 6 has any perfect squares that can be evenly divisible outside of it, and it can't. The only ones I would have are 1 and 4. 1 doesn't do anything, so this is actually done. That's simplified. Example number 2. We take 3 times 2. 3 times 2 gives us 6. And then we take 6 times 3, so that's going to be the square root of 18. Now I check to see if there's any perfect squares that I can take out of 18. 18, I have 9 and 2. 9 is a perfect square. So then, just like we were doing in the last video, we have 6 times the square root of 9 times 2. I'm just going to go ahead and do it completely, and then we'll talk about our little shortcuts that we did last time as well. So 6 times the square root of 9. Remember, we can now split this up. So I have 6 times the square root of 9 times the square root of 2. Now be careful. This is where students make mistakes, because you have to take 6 times. Remember, that's the multiplication symbol there. 6 times 3, and then 6 times 3 is 18. So we have 18 square root of 2. And there's my final answer. Next one is 3 square root of 6 times 5 square root of 2. So again, we multiply out the coefficients first. 3 times 5 is 15. And then 6 square root of 6 times square root of 2 is going to be square root of 12. Now I see if there's any perfect squares that I can take out of 12. There is. It is 4 and then 3. So then I'm going to have 15 times the square root of 4. And then I'm going to jump to just where this next step is to show you. Remember, this step and this step, we can just jump to this one here. They're the same. So then I have 15 times the square root of 4. The square root of 4 is 2. And the easy way to remember that is the square root of it is the number that you squared to obtain it. So the square root of 4 is 2. So if you have difficulty remembering those, that is the easiest way. 15 times 2 times square root of 3. 15 times 2 is 30. So I have 30 square root of 3. All right, this one's a little bit tricky. We've got square root of 5 and then squared. So if you don't know, square root of 5 squared is just the square root of 5 times the square root of 5. And then now I can just multiply inside the radicals. So square root of 5 times square root of 5. So it's going to be square root of 25. And now we know the largest perfect square that we can take out of 25 is 25. And because it's a perfect square itself, then we know that it is 5. And then we're good. Ooh, I forgot to circle the last one. Sorry. All right. Next one, number 5. I'm going to rewrite it again. So we have 7 square root of 3 squared. So that means it's times itself. So we have 7 square root of 3 times 7 square root of 3. Multiply the coefficients out in front. So we have 7 times 7, 49 square root of 3 times square root of 3. That is 9 as well. And then again, we know 9 is a perfect square, so we have 49 times 3, which is 147. There we go. That's not right. 49 times 3. Oh my goodness, I did something totally different. Oh wait, is that right? Man, I'm questioning myself. It is 147. Okay. Believe in yourself, Mr. Broman. You can do it. You can do it too. Had a moment there. All right. Number 6. 2 square root of 2 squared. 2 square root of 2 times 2 square root of 2. Man, there are a lot of 2's here. So many 2's. It's like a ballerina. 2 times 2 is 4. And then square root of 2 times square root of 2 is square root of 4. And then I know the square root of 4 is 2. So I have 4 times 2. So that's going to be 8. All right, next page. So here we have square root of 5 times square root of 20. So square root of 5 times square root of 20, that's going to be the square root of 100. And then the square root of 100. We know because 100 is a perfect square that it's 10. On the next one we have square root of 10 times square root of 5. So that's going to be square root of 50. Again, largest perfect square that we can take out is going to be 25. So then that tells me this is going to be the square root of 25 to the square root of 2. So this is going to be 5 radical 2. On the next one, we have square root of 7 times square root of 7. Now for this one, if we multiply through, we get square root of 49, which is 7. Also, if you think about it, square root and squaring will undo each other. They are inverse operations. So by squaring this, you are actually undoing the square root. So you end up with back just where you started, which is that 7. All right, these last ones are a little bit tricky. Go ahead and pause the video. You've got a good grasp of all of these so far. Go ahead and pause the video, try these last 3 on your own, see if you can get it, and then check with what I have. All right, now that I've given you enough time to pause, let's go ahead and go through them. So first I'm going to start just by multiplying through 24 times 32. So that's going to give me the square root of 768. So now I'm actually going to use our chart that we made earlier because I want to see what the largest perfect square goes into 768. So I can check all of these. I'm just going to start with, I know 400 doesn't go into it evenly just because it's not 800. So I'm going to take 768 divided by 361. Nope, 768 divided by 324. Nope. 768 divided by 289. Nope. 768 divided by 256. Oh, there we go. 3. So it's beneficial, if you don't know, just to start there and just keep going. So 768. So that gave me 3, and I think that was 18. No, 16 for 256. So 256. Now the reason I wanted to remember that it was 16 is because I know the square root of 256 now. So this is going to be the square root of 256 times the square root of 3. And the square root of 256 we just said was 16. And then square root of 3. So that is a lot quicker than some of the other ways students will show me. Some students will fill up this entire page with work trying to get all of the 2's because that's a lot of 2's. But there you go. Now for 11. 4 times 3 is 12. And then let's see, square root of 48 times square root of 12 is going to be the square root of 576. So again, 576, I'm just going to look on this side. So let's see, 576 divided by, let's go 289, start there, 576 divided by 256, nope, close, 576, 225, nope. 576 divided by 196. Nope. Divided by 169. 76 divided by 144. There we go. So 144 and 2. Or no, 4, excuse me. 576. All right. Now, wait a second. 4 is also a perfect square. What does that mean? Well, that actually means I might be able to take the square root 576. It's just past our list. So sometimes this will happen where you have an actual one where it is a perfect square, but it isn't apparent. Now, the reason I knew is because as soon as we got to this, I saw that 144, that's perfect square, but so is 4. And then that gave me the clue, okay, wait, both of these are perfect squares? That means that this has to be one also. So what we actually have is 12 times 24. I just showed you the square root of 576 is 24. And 12 times 24 is 288. So that's 288. And then for number 12, 3 times 6 is 18. And then that's going to be 450. All right. So let's see, 450. 225 goes into that. Yep, 225. 450. And 225, so I know I'm going to have 18 times square root of 225 times square root of 2. That's going to be 18 times 15, right? 15, the square root, yep, square root of 225 is 15, square root of 2. So 18 times 15 gives me 270, square root of 2. I did not circle those. There we go. All right, friends, thank you for joining me in this set of notes. I will see you next time where we start adding and maybe subtracting. Have a great day.